Hello YouTube, this is Mighty Muffin, and today I'm going to show you how to make an automated brewing factory. Now this factory is a little different than the ones I've seen thus far on the internet, as it uses multiple brewing stands and more of an assembly line style of doing things. So let's get started. As you can see, we have 4 input chests that each take a specific ingredient. Now you'll see that these ingredients are immediately being sucked out of the chest. Those are going down into a minecart to be sent into the primary circuit. So now that the chests are full, I'll be back when they've emptied into the minecarts. Okay, all of the chests have emptied out, as you can see. And we're going to send off the bottles and the ingredients. Now I've separated these out because bottles obviously need to be replenished more often, and there was no real need of sending all the minecart chests up every time you had to reload your bottle supply. Now you'll see we have several buttons over here to choose from. This button over here for adding the ingredient to the first brewing stand is only needed when you're starting the process out. Once you've hit it, as long as you don't run out of ingredients in the first stand, you shouldn't need to use this button again. This button will need to be used every time you start the process again. It loads 3 bottles into the first brewing stand so the process can begin. In a moment we'll see that all of the potions being created will be deposited into this chest here. One last part of this control panel is the at capacity light. It will not only light up when there are enough potions built up in the finished product line, but it'll disable the buttons for priming ingredients and bottles so that you don't jam up your circuit. As you can see, we've gotten our first 3 potions, and they are indeed extended swiftness potions. Now let's go back and see exactly what's going on to create these. As you can see, 3 new bottles were just put into the first brewing stand. Basically what happens is when that finishes, this logic changes and allows the new potions to be sucked out and new bottles and ingredients to be added in. At the same time those finish, the redstone signals go down here and do the same thing for these. Fortunately the timings worked out so that no extra measures were needed to make sure these potions finished before they were dumped out. As you can see, it's very well timed, and all 3 stands work in the same fashion. This line of hoppers here goes all the way over to the chest, and as you can see, this is the at capacity mark. Now there's quite a bit of capacity beyond this, but I put it here so that there would be a margin of safety. That line goes both to this light over here and to an inverter, which is an input for 2 AND gates that are used in the pulse limiter. These long piston lines here are just experiments I was working with for vertical circuitry, and well, I made it horizontal too because I was bored. So why don't I show you how to go ahead and make this circuit. Now unfortunately this circuit is a little bit expensive. However, it is approximately 3 times faster than using the single chest or the single brewing stand models that I've seen so far on YouTube. Now you'll want to start by making your tree of brewing stands and hoppers. Okay, now we have our little tree of 3 breweries built. It's time to get the circuit together. Now the top brewing stand is the only one that you actually need outputs determined from. And it's done so by 2 different comparators coming out of it. This comparator to the side here is for determining if the brewing stand is empty. Now this second one with the small network of brewing stands here isn't my design. I can't quite remember who I saw do it on YouTube, but it works nicely for determining when there are 4 and 3 bottles respectively items, not bottles, respectively in the brewing stand. This output here is for when there are not so much 3 items, but when there are less than 4 items in the brewing stand. And this comparator is for when there are 4 items. It will only go active when there are 4 items in the brewing stand. Now this is a small monostable circuit which creates a 1-tick pulse. Using a monostable circuit here because it's going to feed into a T flip-flop. Now this right here with the 2 comparators is an AND gate. Now I've seen multiple variations of comparator AND gates. However, this is the design I like. I know it's not as small as others, but I just like it. Okay, let's explain the logic so far. When there are 0 items in the brewing stand, this torch keeps this line hot and the monostable circuit cannot fire. However, when an ingredient enters here, So there would be one item in the stand at that point. This would turn off, and this would stay on. When the 3 bottles are added, there are now 4 items in here. This goes hot, triggering our monostable circuit to turn our T flip-flop on, which would run this input of our NAND gate high. However, since there are now 4 items, this torch will go low, and there is still only one of the 2 inputs will be high for the NAND gate. Now this NAND gate is where we're going to get most of our inputs for the rest of the circuit. Well, actually all the inputs. The first is going into yet another of our favorite monostable circuit. Apologize, my FPS is a little messed up right now. The monostable circuit then feeds into a repeater with 3 ticks of delay. It has to be 3 ticks, which then goes into an inverter. Damn, what did it do? Doesn't matter. Now we want 3 ticks for that, so that one ingredient and only one ingredient will be added to this brewing stand. If it adds more, we're going to have issues because it will invalidate the outputs coming out of the comparators. The next task is to take this over to the output hopper. Now when the circuit finishes, okay, let's give you the basic rundown now. So you have 4 items in the stand now. So this T flip-flop is extended and this line is off. When it finishes brewing, this T flop stays extended, but this line turns on, which turns the NAND gate off. When that happens, 3 items, all the potions are removed from the brewing stand, which now causes there to be 0 items. That will cause this to actuate, and the T flip-flop will turn back off, reactivating this line, triggering the monostable circuit, and for 3 ticks, it will turn off this redstone line, allowing the hopper to put one of its ingredients into the brewing stand. Now the last part of the circuit is to add new bottles into the brewing stand. Now there are many ways to do this. We basically need a double pulse. This is the method I came up with. Not sure if it's the best, but it's the one I like. This needs to be at 2 ticks, and we're going into yet another monostable circuit. And a second monostable circuit here. Now we need 2 monostable circuits because we're going to have to put a line entering around here to trigger this circuit to actuate for the button that initially feeds the bottles in. And you'll see as we connect this circuit here, the piston will turn off the T flip-flop. This is Q0, by the way. And after 12 seconds, it'll turn the flip-flop back on. "12 ticks is more than long enough to put 3 bottles in, but since it can only put 3 bottles in, it's better to err on the side of safety for that part of the circuit. Now all that's left is connecting the corresponding hoppers on these lower stands. You don't need any special timings. I tend to put repeaters at the stands just to make sure the signal is going to be there for testing purposes. But it's not really required unless you exceed the 16 block limit. Thanks for watching. This was my first YouTube video, so if you have any suggestions or constructive criticism to help me make my videos better in the future, it would be appreciated.